Okay, so they say a farmer wants to build a rectangular camp with a perimeter of 120 meters so that it encloses a maximum possible area. Now this is a weird concept to wrap your head around. If you have 120 meters of fencing, soos draad, as jy 120 meter draad het, kan die oppervlakte wat jy daarmee toemaak drasties verskil. I'm going to repeat that. If you have 120 meters of fencing, then depending on the shape that you enclose, the area can change a lot. So if we have time, I'm going to show you different examples of that, where if you do the perimeter, you still get to 120. So you can have a square or a rectangle or whatever. And the dimensions of the shape actually changes the area, even though the perimeter stays the same. Okay, so let's say, so he has 120 meters for the perimeter. If the length of the camp is x, find out the value of x for the area to be a maximum and calculate the maximum area. Okay, so we're going to take that and calculate the maximum area. So this is a practical application. Imagine you are on your farm one day, you have 120 meters of draad, and now you have to enclose an area, and you want that area to be as big as possible, want dan kan jy soveel as moontlik skapies insit. Okay, so we start off by saying, what do we know? They give us that the length is x. Okay. And then I'm going to say, kom ons maak die breedte gelyk aan b. You can make that y as well, but you guys are with me still. So, they say, daar's baie verskillende waardes waarvoor x en b 'n omtrek van 120 kan gee, but the formula will look like that. So, if you have x is equal to 50 and b is equal to 10, do you guys agree the perimeter will be 120? Because it's 50 plus 10 plus 50 plus 10. Right? So it's 120 for the omtrek. And then the area will be 500 cubic meters. Or if you have 40 plus 20 plus 40 plus 20, then you once again have a perimeter of 120. But this time the area is 800 cubic meters. So do you guys see the perimeter stays the same? Die hoeveelheid draad wat jy gebruik bly dieselfde. Maar die afmetings maak dat die area wat jy toemaak die hele tyd verander. And what we want to do now is we want to get those measurements to have that area at the maximum value. Okay, en ek gaan nou vir julle verduidelik hoe ons dit met calculus inskakel. And then they carry on, you get the idea. Blah, 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 blah. Okay, another example, still 120 for the perimeter, but now the area changes again. Okay, in ons stel belang in die maximum. Now for that, we're going to jump back to calculus quickly. Now remember, when we have in calculus, quickly going to write this on the whiteboard. You don't have to write this down. That parabola. Right? What did we learn about the maximum value if we have the equation? You set first derivative equal to 0. Onthou julle? Vir 'n maximum of 'n minimum waarde, kry jy die vergelyking en jy stel die eerste afgeleide gelyk aan 0. Because we got the turning points, the stationary maximum value or minimum value. Do you guys remember? When we had a cubic graph, it looked like this. Dan vir hierdie twee punte, sê ons mos, eerste afgeleide gelyk aan 0. Do you guys agree? That is a local maximum and this is a local minimum. So when they're looking for maximum or minimum values with these practical applications, just always remember first derivative equal to 0 gives you the maximum value. And that's what we're going to do now. But you have to start off by setting up an equation for that specific one. So wat weet ons van hierdie? We know that 2b plus 2x must give you 120. Hoe weet ek dit? Want ek weet die omtrek moet 120 wees. How do we get the perimeter of a rectangle? 2 sides, 2 lengths. Né? 2 lengtes, 2 breedtes, gee mos vir jou die omtrek. Where did I get that 120? They gave it to me. Okay. Is almal nog by met wat ek tot daar gedoen het? I just got it in terms of B. I'll show you why now. Yes. Okay, but it doesn't matter because then the two values are going to equal one another. But you don't know that starting off. So if this is a square, then you'll get to x is equal to b, which means the length and the breadth is exactly the same, making it a square. But don't break your brain about that because it won't always be a square. Okay, good. Now we write it in terms of x. So we know that we are looking for area. Okay, so wat jy altyd hier gaan doen is jy gaan twee verskillende stukkies inligting moet merge. But what do we want the maximum of? We want the maximum area. So now you need to write down an equation for area in terms of just one other variable. So at the moment, I have area is equal to x times b. That's too many variables. Ek wil net een veranderlik hê. So nou kan ek gaan en sê dit. So I'm using this top equation. Kom nou, Pilkie. I'm using this top equation to get area in terms of just one variable. Because if I have it in terms of just one variable, I can easily get the derivative. Okay, hierdie maak nie nou saakie. But do you guys see that that is a parabola? It has an x squared in it. Okay, this is in fact a parabola wat deur die oorsprong gaan. So this is an equation for area, but it is also a parabola. And do you guys agree that that value is the maximum value? So if I can calculate the value of x for that turning point, then I have the maximum area of this rectangle. Okay? And that's what I'm going to do. First derivative equal to 0. Okay, so the derivative of that one is nice and easy to find. You solve for x, meaning that, remember that that's only one of the dimensions. Okay? So die een afmeting moet wees 30 meter. Now how do I solve the other one? We know that 30 times the breadth must give you, no, I'm lying. Not 30 times, you put it in this one. You already have an equation. Okay, exactly what Lauren asked earlier. Do you guys see? What type of a shape will this be? A square, because x and b, they're both 30. Okay, now, pro tip. This is always true unless they give you one of the sides. So what they sometimes do is they say you are building a camp, but you are using an existing wall for one of your sides. Okay, so then you have just that, x, b, x, for instance. Then your answer won't be a square. But if it's like this, the biggest area that you can have for a rectangle is a square. It's just a fact. It's always going to be a square. Okay, so you can check yourself with that, except in that case. Okay. And I ask you to calculate the maximum area as well. And you can go and check. There's no other dimension that will give you a bigger area than 30 by 30. And still adds up to a perimeter of 120. Okay. The important thing that you guys need to understand is that we are working with calculus. But you have to first set up an equation that you can get the derivative of. Okay. Good. Example 2. So, they want to sell a can of soda which holds 250 cubic centimeters. So it's 250 milliliter. They want to use the least amount of tin possible, want dan is dit mos nou minder produk, né? So is goedkoper om te vervaardig. So hoe minder van die stof jy gebruik, hoe goedkoper is dit om 'n blikkie te maak. Calculate the dimensions of the can for the total surface area to be a minimum. Why do we want it to be a minimum? Because we want the total surface area to be as small as possible, want dan gebruik jy die minste stof. Do you guys understand? Now, once again, for minimum value, it's just going to be a parabola with this shape. Right? Because then minimum value is there, where its first derivative equal to 0. Okay, but this is jumping ahead. We need to start off by getting an equation that we can derive. So, they'll probably give you this formula if they want you to work with this one. Okay, formula for the volume, formula for the total surface area. I don't know if you guys can remember that, but it's fine if you don't. Okay, so we're going to work with that. Which one do we actually know? We know what? We know the volume. Do you guys agree? Okay, but do you see that the volume has two variables in there? Remember, pi isn't a variable. Write that down for you guys. Pi is not a variable, it's a number. What's this number? 3,14, whatever. Okay, but it sometimes throws us off because that looks like a variable, but it's not a variable. So don't try to replace that with something else. It's a number. Okay, but it is in terms of R and H. So we need to replace one of them with the other. No. Okay. So I'm going to use the one that I have, and they're going to say, do it in terms of R. I have the height in terms of R. So the only thing you do there is you just move stuff around. Okay, do you guys see I said divided by pi R squared. So then I have H in terms of R. It's not in terms of anything else. We'll talk about that when we're going through your paper too. Remember, if they ask you for something in terms of M, then there has to be only a M in your answer, no other variables. Numbers, no other variables. Okay. And then, once again, what do we want the minimum of? For the previous one, we wanted the maximum of the area. So you set up an equation for the area. What do we want the minimum of? It's in the question, the total surface area. So that's the one that we need to set up an equation for. Okay, so they gave you that equation for the total surface area, and you guys see I can go and substitute that in there. En as jy daai ene daar gaan inmaal, het ons die totale buiteoppervlakte in terme van net een veranderlike, naamlik R. So then you can get the derivative and set it equal to 0. So this is just basic simplification. Okay, the pi and the pi cancels out. R cancels out one of those, and 2 times 250 is 500. So it's just being substituted and simplified. Okay. Hierdie ene het daai R kwadraat. So we're going to derive a minimum value for a positive parabola in terms of R instead of X. But do you guys agree that this one is difficult to derive as is there? So what do? We write it as 500 R to the power of negative 1. Onthou julle by die differentiaal kry julle eers dat hulle makliker is om van 'n afgeleide te kry. So we set the derivative equal to 0. That's the area, the one that I just said. Write it like this, because then it's easy to derive. That's the derivative. You see they say area or total surface area in terms of R. Ons het altyd gehad afgeleide van Y in terme van X. Okay, but when we start doing the questions together, I'll spend more time on the writing of this. Okay, but what do I do with this now once I have the derivative? Equal to 0. Okay, en van daar af is dit net oplos. So they times by R squared, and then you get this cube root of that. Why don't I write plus or minus? Okay, well, it's a cube root, so it can't have a minus. Maar kom ons sê dit was R kwadraat. Hoekom hoef ek die plus of minus te skryf nie? Radius is a lengte. Do you guys agree? So then it can't have a negative value. This one can't have a negative value anyway. But you don't have to write it down. Okay, so vir die kleinste hoeveelheid, wat het hulle gesê is 'n tin wat jy gebruik, is die radius van die blikkie 3,41 centimeter. Okay, and then they work